Welcome back on board the Starship. I'm talking with Keith Hunter, who is the author of The Lost Age of High Knowledge.
Yes.
Now, here's the question then, Keith. If the Earth was smaller, I would have expected it to have less mass and therefore be in a, going by the law of gravitation, it would be further out from the sun, therefore it would have a longer year, therefore it wouldn't be 360, it would be more than 365. So how, because I know that you don't really get too much into considering Newtonian laws of gravitation. You go more by the Kepler ratios. So can you just speak about that, Keith? How could the Earth have possibly shrunk, or sorry, not expanded by this amount?
Well, what I have found is in evaluating the change to the Earth and also the Moon, I've also looked at other things, not just astronomical things, not even just the planets in the solar system, the other planets in the sun. And I found that there seems to be an order to various values. Say, for one example, is the table of elements. We've got like melting points, thresholds for various things. One such threshold, for example, is the melting point of carbon in the form of diamond. It's about 3,550 degrees. But it's very close to 3,600 degrees. And if you reduce 3,600 again by the same ratio that you have for the Earth,
365.25 divided by 360.
Yeah, if you take that ratio, so you take 3,600 and divide by 1.01456, you almost get bang on the melting point of carbon.
Right.
So I can see that we've got shifts in elements like that.
Right.
We might even think about the human body. We use degrees Fahrenheit. The optimum temperature for the human body is 98.56.
Yeah.
Why is it not 100? Because the Earth's changed its orbit.
Right.
If you took the number 100 and divided by the same ratio for the Earth change, you get 98.56.
Right.
And I think that you've also got other constants, what we might call as a gravitational constant, also the speed of light. I even have a law of proportion that transforms the speed of light. So for me, there are so many other things which have been dynamically transformed in unison. And this is why, if we try to use just basic Newtonian laws in a fixed system, right, you're right, it would contradict the changes I propose. But I propose that the laws of proportion can be extended and they appear to apply to many things. So we've got a full universal shift in all these values.
What you're saying is something's changed at some point in time.
Something has changed very dramatically.
But you think that it seems to be the circumference of the Earth, but maybe not. Maybe some other fundamental physical constants have changed, which just, I don't know.
Well, I do believe that the Earth has really changed its actual size.
So you think it's increased by 357 miles?
The actual circumference has increased from 21,600, what I term ideal geographical miles of 6,000 feet, yeah? You take that figure, 21,600, you multiply that by the ratio of change for the Earth's orbital period, and you get what is a very accurate fit to the real circumference of the Earth right now.
Yeah.
And so, again, this is evident if we use units of 6,000 feet as a standard, which is basically a fathom times 1,000, right? 1,000 fathoms, because a fathom's 6 feet.
Yeah.
So I'm just extending it further in that way.
And in the same ratio, the Earth's year has increased by that same ratio, although I don't think you can actually describe the mechanism as to why the Earth year is longer. Because for me, if the Earth's had more mass added to it, then it's attracted more to the sun, therefore it should be in a tighter orbit or a quicker orbit.
In my book, obviously a lot of physicists and astronomers are familiar with what is a general inverse square law.
Yeah.
And it's based on the powers 2 and 3.
Yeah.
Kepler's law is the one, right?
Yeah.
And it extends away from the sun. Well, I've actually done a study of all of the planets in the solar system and reconstructed the original system. And one of the key things I found was that this general inverse square law does not hold for the solar system. What you've got are a series of bands, right, extending forth from the sun. And each of the planets is in a certain band. And there are laws of proportion which connect up the orbital period of the planet to its semi-major axis, and they are transformed using different combinations of powers, and not just 2 and 3,
Right.
And so this general inverse square law couldn't hold to unify the solar system. It's like a special case, and what you've
Right.
got embedded within are all these different bands and different laws.
Right. Okay. So, I mean, one other person that I've heard say this is a guy called Stan Deo. I don't know if you're aware of his theory on gravitation, but he says that, and I don't agree with it though, by the way, that you've got the sun, which normal Newtonian gravity says that the force of attraction from the sun falls off by the inverse of the square as the body gets further away. But he says that it's actually a standing wave, and there's crests and troughs, and that the planet has to get in a trough and go around. So that it's actually like, imagine if you had he actually demonstrates it with a lemonade bottle, and he vibrates it, so you get these standing waves. And he says that there's these standing waves in space, and the planet has to be in one of the grooves to be in orbit. I mean, I don't agree with it because there's nothing to reflect the wave to make it into a standing wave. But so you would say that the general inverse square law of gravitation is not completely true?
It doesn't hold to model the planets about the sun. In fact, what you've actually just said about these standing waves, I've not heard that theory, but it sounds brilliant. It sounds very decisive, actually. Right. Because in terms of the ancients themselves, they held, or they described what they referred to as the solar system as an operational system. They referred to it as the music of the spheres.
Yeah.
Every planet is sounding out its signature frequencies. Now, I couldn't tell you whether we're talking about the electromagnetic spectrum or sound waves, but they are sounding out their frequencies, and the sun itself will be radiating out its sounds. And so it would have peaks and troughs, and you would have special wavelengths.
Right.
And so all of the planets are sounding out their frequencies, and every planet is raining down its signature on every other.
Right.
And so this is why you have certain resonance effects within the solar system.
The other thing that Deo claims is that this is only possible because the mass of the sun is not distributed evenly. So it's like it's sort of doing this, which is what's pumping the waves out. If it was a perfect sphere with perfect mass distribution, it wouldn't work. That's what he reckons. I mean,
I'd agree with that as well, because one of the theories I developed concerns earthquakes, which I believe are caused by matter transference between the celestial bodies. So I believe the sun, all the planets and the moons are continually engaged in shifting matter between themselves. Right. And that's partly explains why you're not going to have a fixed mass for any given body.
I mean, we're digressing a little bit from what we'd planned to talk about, but I want to stay on it actually, Keith, because you've got the sun, you've got you've got Mercury, you've got Venus, you've got from my knowledge of conventional physics, the placement of those orbits is determined by the mass of that body and the speed that it's going around, or in other words, the centripetal force pushing it out has to equal the gravitational force, and that force gets weaker as it gets further away from the sun, right? So you're saying that the planets aren't following those rules of the Newtonian law of gravitation.
That's exactly what I'd say.
That's exactly what you're saying. So if I was to get the mass of Mercury, the mass of the sun, and work out its orbital period, you're saying that the maths don't add up?
Well, what I'm saying is this. That kind of system as a model models a dead system. Right. That for me is, you're looking at a lump of stuff. It's almost like you had...
it has a field around it.
Yeah, you could even model that in if you had like a special spherical, everybody gives the analogy. Yeah, the trampoline. You put a little weight in, and you get a nice little curvature. Yeah. And you can imagine little billiard balls going round. Exactly. And you could get that curvature modelled to model even a general inverse square law. Yes. And you could set them all in motion, and I'll bet that model is perfect. But it doesn't apply to the planets. Right. They don't operate in accordance with a dead model like that. They're a lot more dynamic, right? Okay. Do you understand?
Right, so everyone with a physics qualification will be sitting saying he's talking shit. But,
they will, yes. But he's not just that, he's talking shit without a physics degree. Yeah.
So how can you... I mean, obviously we might not have time to go through the maths of why you think this, but just briefly explain, have you done calculations on the planets in their orbits and shown that the orbits are wrong, or
It's not so much that. The orbits as they stand, obviously, it's physically as it is. But what I am saying is that, and this actually became decisively clear to me from studying the moon, because I said that the moon itself once had 30 days to a month, right? And currently it's about 29.53 or so. Now, one of the laws of proportion I came up with tied in the semi-major axis of the moon orbit, that is, it's the mean distance between the moon and the earth. And it said that as the moon increases, moves away from the earth, right, this would have accompanied the increase in the earth's orbit itself from 360 to 365, and also the expansion of the earth at the equator. So what I'm saying is, as the earth orbital period has increased, the physical expansion of the earth has occurred, the moon has extended its distance from the earth, but at the same time the moon has decreased its orbital period. So in other words, the further away the moon seems to get, the faster or the shorter or quicker the time to make one orbit. But that law flies in the face of any general inverse square law based on these standard gravity models. And this is why I make a critical distinction between what I refer to as the manipulation of the system and the transformation of it. And these laws are found for the planets in their different bands. They all appear to be transformational laws. They accompany the transformation of things like the speed of light or the elements, or I would even say the so-called gravitational constant. They would all be dynamically transformed, all these things occurring. So the orbital distances will change as the mass increases, as the volume changes. And this is totally different on a different level than the actual manipulation of a system, which is based on fixed values. And this is why there's this, seemingly disagreement between the Newtonian model you've given and the model that I'm trying to explain here. I think that they're not. I don't think they're in conflict. It's just that I'm talking about almost the evolution of the solar system rather than its manipulation.
So you think that in order to explain how the moon could have got further away, but be in a faster orbit, which flies, as you say, in the face, you think when that change has occurred, when it's moved further away and going around faster, something fundamental has changed to allow that to happen. The system's changed.
For a start, the moon has shrunk slightly. There's a law of proportion in my book for that. So I think the moon has shrunk slightly. So then we'd be talking about the mass of the moon changing. We'd be talking the mass of the earth changing, things like that. We'd also be talking about the shift in these bands that the moon and the earth is operating in. So again, the complexity of it is such that I do believe it's perfectly lawful, but it will give you changes to these orbits which you could not explain using basic Newtonian manipulations.
There's something else at play other than your bog standard Newtonian laws of gravity. All right. Right, and Keith, well, it's fascinating stuff, and we're going to talk more after the break. We're going to go into the pyramids. But before that, it's time for this week's Poet in the Pub.
Metrosexuals. You know what metrosexuals are? You've got blokes walking around with money and they're in touch with their own femininity and all this, They're not the same as gays. They're just fashion people, really. Yeah, because they define who they want to be.
Yeah.
Will bend over sometimes,
Yeah.
That kind of thing.
Like
really
the buy men's magazines, that kind of person.
Yeah. FA Chairman, all them.
All them crap.
I used to buy Loaded a couple of years ago and it was worth reading.
Just get razzle now.
Don't buy anything now, don't have to. Shoot all metrosexuals now. Mincing in the clothes shop queue, the blind leading the blind. I'd go ballistic if one ever nudged me from behind. They don't like my friends and me and say that we look rough. Their fashion game is really just a game of blind man's puff. Shoot all metrosexuals now. The only question's exactly how. Shoot all metrosexuals now. The marketing people's sacred cow. I don't need your noncy job to be a man. I don't need your money, because I take things when I can. Have you paid your taxes, son, you tool of self-control? Even if I'm dressed in rags, I can get my hole. Shoot all metrosexuals now. Tax them more because they're thick. Shoot all metrosexuals now because their bentness makes me sick. Sitting in the gastropub, nouvelle cuisine and wine, wasting loads of money because they think it's modern times. Stride up next to one of them, knock over their carafe, and listen to them mewling. What a f***ing laugh. Shoot all metrosexuals now, for the sake of decency. Shoot all metrosexuals now, it's not the time for leniency. Shoot all metrosexuals now, dance a jig on their mass graves. Shoot all metrosexuals now, because society must be saved. You can't really tell that one to people around here. They don't know what it is.
Aye.
But if you see it in a major city, they know what it is.
Aye.
Yeah. Newcastle is chocker with them.
With metrosexuals.
Yeah, puffy your feet students and all this kind of carry on,
Yeah.
you know. People with disposable money. People with a lot of disposable money,
Yeah.
you know.